o'clock in local time. I mean in Melbourne. Thank you very much for attending this tutorial, this first tutorial on behalf of the organization, the organizers of the tutorial, so myself and Arthur Perosvede. We would like to say thank you to all the submitters to the tutorial and the speakers of the tutorials accepted. I mean, this is the first one that will be held by Jan Mendling. It is co-authored with Monika, Malinova, sorry. I think that Jan has not, I think everyone knows Jan. He's full professor now in University of Hamburg in Berlin. He is one of the authors, the 4 authors of the best-selling books on business process management, and he has his main research interest is in business process management, mainly process mining, conceptual modeling, and many other things, let's say. And even if Monika is not attending today because for some family reasons, good family reasons, I would say. I would like also to introduce her. She's a postdoctoral researcher in Business University of Vienna. I don't know how to say in German the name of the university. I'm not trying to do it, but even if she's quite young, she has a good record of awards, like the Dr. Maria Schaumeyer Award for Excellent Dissertation in 2016. She also got the fellow in the Hertha Finber Fellow, funded by the Austrian Science Fund, and many other awards. Also, the research of Monika the research interests of Monika include business process management, innovation, and conceptual modeling. So today, this is a tutorial concerning conceptual modeling, and in particular, the relationship between conceptual modeling and cognitive computing. I don't want to take additional time to Jan to present his interesting work. I leave the floor to him. And I remind you that there is a function at the bottom of your screen called Q&A. Every time you would like to ask for a question, just write there, and we will manage, in case it is needed, to also open the mic to the people that would like to talk. Or if you think that putting the question, writing the question in the panel in the chat is more than enough, we can manage in that way. So enjoy, and Jan, the floor is yours.
Thank you so much for this nice introduction. And I switch over to my visuals. So you should be seeing my slides now, and if not, please let me know. And Monika also says hi, actually as Gigi said, for good family reasons. So her family has just been extended by another person. So she's not able to join us today, but I will take over. So what we will be focusing on is on a cognitive perspective regarding diagrams. Diagrams and models playing an important role in information systems engineering. The challenge with that matter has been for a while that empirical works have been showing into different angles and different directions. Partially these empirical research have been inconclusive. So we felt the need that actually we need to take a step back and create a broader overview of that topic to see how all of these empirical works map out. So as being said, well, you can use the chat window. So I have an eye on the chat window, and Gigi and Aika as well. So if there are any comments and questions, please make use of that facility. that you can then actually interact with us. And I hope that we will also have some discussions along the way and some different thoughts that we can share on the topic. So for starting, actually, I would like to ask a little bit into the audience in how far, what is your take on models? So what is your take on diagrams in information systems engineering? And you know also that in the Zoom system that we're using, you can raise your hand, and by raising your hand, you can say yes to the following questions that I will be asking. So, and I'm curious to see what is, let's say, the larger picture here in the audience. So, and let me start with the first question. Do we like models? Let me try to extend the list of people that I see the people. All right. Great. That looks nice. So people like models. I also do like models. But what is the more important question, actually, I would say, is, let's look at the second question. Do you think models are useful? All right. Also, a lot of people actually say so. Okay, that's nice. And maybe let's use the chat function. I would be happy if you could write one or the other comment or a keyword. Why do you think models are useful? I'm looking at the chat window, and you can look at some of your thoughts. So general overview is being said, starting a discussion, conveying ideas, analyze, finding errors, having abstract concepts for communication, a common language. They help in abstraction, they help to understand systems, they help in training, means for communication, analysis. Let me see, one or the other person might still be typing. Validate requirements with stakeholders is being said. Simulation. We can create to-be models. Help us in design. Improvement, applying design patterns. All right. Thank you very much. A lot of ideas, a lot of perspective on models. And as you emphasize, models unfold their benefits and that they help us to do certain things better. And I think that's the key observation from which I want to start here, is that by having models makes a difference. So if we have a diagrammatic representation of a certain matter, so for example here, I picked a business process, we face the alternative that any sort of information that we want to actually capture and represent, and that we can put in a diagram, of course, we can also write it down as a piece of text. You see this here, that it is actually the same process that is being described by a piece of text and with a diagram. And these two representations are information equivalent. So it means the text that you see on the right-hand side is exactly showing what is in the diagram. And there's certain things that you may observe when you look at both, that the diagram may be better in one or the other regard. We're trying to discuss this more specifically along the way today. But it's not only diagrams versus text that we can actually discuss. It is also, if we assume that we use a diagram, it makes a difference how we use diagrams. Here's an example that shows the same process. It's a workflow representation. what is on the right-hand side to be seen is that, that there are different split and join points in this diagram that match each other. These are highlighted in the same color if they correspond. So if, for example, you look onto the left-hand side branch of the colored model, you see that there's something like a purple element and a second purple element. And for that one, it's actually quite easy to see that they correspond to each other. So it's like an opening and a closing bracket of the same split and join element, such that this creates a fragment of the process. And this is often interesting and important to understand in such a process model, that you can understand which parts of the model belong together and which of them form a component, such that you can look at the functionality and the behavior of the process in a decompositional way. So here, but logically, it's still the same process model that we are seeing here. But on the right-hand side, due to this color highlighting, it is more beneficial for a person to look at it because we can more directly see what are important parts of it. All right, so you see also here with let's say, if you look at the references to which these examples refer, that we have been doing various experiments on models over the last 10 to 15 years in order to understand one or the other effect that different representations have on how different types of models can be better understood. And one thing that I was always struggling with these experiments was that I did not get to see that there was something like really like an overarching piece of work that explains, let's say, how things are actually connected on a more meta level, in which all of these experiments could fit. Because there's so many aspects that you can actually consider when you design an experiment, for example, and also how different factors at all kinds of levels have an influence on, for example, here, how well you understand the process. So that at some stage, with this feeling that this overarching framework is not, let's say, as it would have been helpful for me in my experiments, we felt that maybe we should start thinking about writing a piece that tries to summarize this. So and that brings us to this paper, which is then also an anchor for this tutorial today. It's a paper by Monika and myself, which was recently published in MISQ, and it's also open access available, so you can find the PDF on the MISQ website. And it's trying to establish such a larger framework that is able to identify the different concerns that contribute to an understanding of a diagram from a really like a holistic perspective. So, and let's say the key perspective of this framework is that that one of the things that I felt was often difficult when designing experiments is actually the fact that, well, for having an experiment with users, you have to give them tasks. And many of you know that when you look at how conceptual models are often defined, that you find that actually right away in the definition. So it's a representation for a particular purpose. Funny enough, in many of the works that you find in the literature, this emphasis on the purpose, on a particular task that a user is after, is actually not so explicit. And I want to highlight that with one of the very recent works by my friend Jan Recker and others, where they have been reflecting upon how the overall conceptual modeling research agenda is changing. due to physical and digital reality being changing in their intermutual relations. And what I find striking is, of course, there are many aspects and many facets that such a topic has, but also with reference to earlier frameworks. Most often, the perspective on the tasks is not very explicit. So, I think this is a little bit like the elephant in the room in conceptual modeling research. Tasks are in the definition of conceptual models, but often in our individual research studies, we don't look at them too much in detail. So it's, in a way, it's somewhat like a little bit hidden in this recent work by Jan. But I think that is important, and that is one thing that we have to take as a starting point, that in the end, diagrams capture information, and this information needs to prove itself valuable with reference to a particular task. So it means, if you look at it, let's say from the framework that I will also later refer to for establishing that argument, we can actually look at what is the cognitive process of somebody working with diagrams. And I'm kind of, let's say, presenting this now from the right-hand side to the left-hand side. So usually when you would see it in the paper, of course, your first intuition would be from reading that from the left-hand side to the right-hand side. So let's have a look at that. Key observation is, let's say, when you emphasize this matter of a purpose, well, why do people actually look at diagrams at all? They look at them because they're after working and performing a particular task. So it means actually what we try to achieve is a good task performance, and these diagrams actually help with the task performance. So if you then try to look at what is, let's say, from a cognitive angle important for making this task processing work, you can locate the task processing cognitively in a mental module which is called the intentional module. So this is a part of our brain. So there's been research actually that not only emphasizes that this conceptually exists, but this is actually that there are physical parts of our brain that correlate actually to this processing. And that is concerned with taking a task and step-by-step developing a goal hierarchy, such that we as humans can then step-by-step work on, let's say, the smaller pieces of the task and step-by-step puzzle them together towards the overall task is solved. This is a general principle of how our brains work, and it's what has been studied over the last 50 years in cognitive research. So that means actually when we are facing the challenge of working on a particular task, we need to consider that at several stages, we need information that helps us to solve these tasks and that work upon. And here, actually, the overall cognitive control is organized by the central executive, that actually the operations in this intentional module are coordinated with other cognitive modules. And important is that for actually working and processing in each of the modules that we will see in a moment, we need some specific knowledge that typically resides in our long-term memory. In particular, when it refers to tasks, we need to have means-ends knowledge. That means we need to understand, if we are facing a particular task, how we're going to do it. Yeah? So this is the knowledge that we require for breaking down a task into such a goal hierarchy for which we then can step-by-step process. So That means once we have, let's say, this goal hierarchy is dynamically built and also resolved, we then face the challenge that at different stages we need information. And this information may be information that is residing in our brain, or it is information that is not readily available. And here diagrams come into play because they may serve as either as an anchor for certain pieces of information, or they may fully represent a particular sphere of information that we need for a particular task to understand. So, and this is then where this task processing interacts with semantic processing. The map against which the semantic processing is being managed is a mental model of a diagram that is, of course, not isolated, but it's connected with all kinds of background knowledge that we may have. It's background knowledge that we possess in terms of modeling knowledge, and that means what are different diagram concepts and how they are supposed to be interpreted and what they imply. But it's also domain background knowledge that we possess. And at the semantic processing level, this is all intermingled and mixed together and provides the informational entity against which the task processing can be performed. So for that information that is not residing in our brain, we need to acquire that externally. And that is being made available to the semantic processing through the stages of visual processing. So that is at the stage where we visually capture and we read certain pieces of information. For that, we need some very generic Gestalt knowledge, how we can interpret certain visual entities, certain objects, lines, etc. And it also requires that we process the textual pieces of information that are in diagrams. And all this is feeding into the semantic processing. So you see here on the left-hand side, finally, we see the diagram and a diagram or several diagrams or other pieces of information feed in through the visual channel and the verbal channel into the semantic processing, and then is being actually consumed at different stages of task processing. So let me have a quick look. There's something in the chat window. All right. All right, I think, well, I cannot read the name, but it is, of course, a pointer that this is very related to frameworks like SQL, for instance. And, you know, John is in the webinar, and he's been working on it over the last 25 years. So I'm curious when we can see how actually we can discuss the integration of all of this. All right, so that means kind of the, let's say, to summarize this here, I observed that much of the empirical research that I've been seeing in the conceptual modeling side is actually often coming, let's say, in this way. We study diagrams and we take diagrams as a starting point. And when we want to create an experiment on diagrams, at some stage, we have to choose some tasks in order to check if the diagrams are working well and nicely. While we actually try to emphasize here, actually, we have to ask ourselves the other way around. What are actually the tasks that people are concerned with when they do system analysis and design, when they engineer their systems? And then the question is, in how far can diagrams be supportive for capturing the information needs, for addressing the information needs in a suitable way in order to serve a particular task. So this is what I like to discuss with you in the following in more detail. So it means kind of, let's say, the overall argument that we bring forth in this tutorial and also in this recent paper is that depending on the system engineering task you're looking at, diagrams can be helpful if they serve the information needs of that particular task and if they meet criteria of cognitive effectiveness. Yeah, so that is the key. That's the key question that I want to discuss with you. How do all these different how do we actually can talk about cognitive effectiveness, and what are, let's say, what's the big spectrum of criteria that are actually coming into play here? All right, so let's delve into that in a little bit more detail. So it means when we want to talk about how diagrams are useful, we need to reflect upon the tasks that these diagrams are meant to serve. And I think that is actually one of, let's say, the big confusions in much of empirical research on models, because let's say often you find the assumptions that diagrams are good or bad, let's say in a more generalistic perspective. But it's not too often discussed with too much sensitivity of the particular task that we are looking at. And I think that is key, that while we observe sometimes diagrams perform well and sometimes diagrams don't perform well. It's partially explained by the task at hand that we're looking at. So, and for structuring this a little bit, I want to briefly relate this to a very generic framework that we used for organizing our argument a little bit. And you may want to say, of course, there are other frameworks, and of course, there are also many more detailed frameworks. For instance, if you look at the CAiSE or other initiatives that have tried to taxonomize different task and system analysis and design. But I think for the moment here, it suffices to say that let's say from a very coarse granular perspective, what we try to do is when we engage in systems engineering or system analysis and design, is that we try to understand a particular usage situation of the envisioned information system. From that, we try to construct a requirement specification, which we can then actually use to inform the system design and specification, which can eventually be implemented as a system. So for those of you who think that looks a little bit like waterfall here, I'd like to emphasize that this is, let's say, a representation that captures the conceptual dependencies here. And of course, there jumps back and forth. And there's also empirical research in how far, let's say, the concerns of the design process is moving from the left-hand to the right-hand side. But still at a later stage, you always find that you discover something which leads you actually to take a step back. But let's say what also empirical research says that that these back jumps become less with the progress of a project, and also the extent of these back jumps. So that means how much actually you still need to revise on requirements and design specification when you start implementing, that this is becoming less and less. So there's clearly a flow to the left, to the right on the conceptual perspective. You also see here that this is a little bit framed in these gray boxes, I keep it short, but in essence, this is referring back to one of the conceptual works by Karl Popper, where he speaks about 3 different worlds as a means where he's trying to organize a little bit where knowledge resides and how we can actually obtain knowledge. And according to this framework, we can see that actually where the user situation and the information system that is actually then finally about to run, they are meant to actually be located in the in what we often call the real world or the physical world. Each of the specifications along the way are actually abstract knowledge entities. And what is interesting here is that, well, with any steps of how we progress in our design process, it is actually activities that are residing in world 2. And that means any of these steps where the design progresses is something that humans drive. So it means we are always faced with the challenge that any of the tasks that are being done are being done by humans, or if they are automated, they're envisioned by humans to be done in one or the other way. So it means much of these tasks reside in world 2. That means it's actually the world of the psychological states of the analyst. And that clearly emphasizes that it is suitable to take a cognitive perspective to talk about these tasks. So, and now when actually we pick one of these tasks along the way of this design process, no matter if that is a task that is, let's say, at the very beginning of the design, which is often very fuzzy tasks of understanding of who are the stakeholders, what are the requirements, towards, let's say, closer to the implementation, where tasks become actually very narrow and specific, we can see that diagrams are being used in practice and that they are appreciated for certain benefits that they provide, all of the things that you actually mentioned earlier. And these benefits, they have to do with certain characteristics of diagrams. And we see here that diagrams are a type of representation that mingles together characteristics of images with characteristics of text. And these different pieces of information that they puzzle together are here being highlighted in red and in blue. And you see on the left-hand side in blue that we have in these diagrams typically text pieces. So this is really, well, it's sometimes here like in this order received, it's a verb phrase. Sometimes it's only terms, but sometimes it's also that you can actually see like people almost writing proper sentences in different parts of a diagram. So then we have also glyphs. This is the element in the very middle of this diagram, this X. So this glyph is actually a letter, the letter X, and it has a particular meaning, and that is connected with its character, with the character X as a letter, because it's an abbreviation for the term exclusive. So that actually points here to the semantics of this element. And then we have shapes. Typically, much of the elements in these diagrams are being shown as shapes, round shapes, rectangular shapes, squares, ellipses, etc. And these shapes may actually be surrounding text, like here, like the deliverable product activity, or they may actually have ideograms inside. So this is what you see on the right-hand side at the top with this little envelope. And then you have lines with which you can connect these elements. So, and as we will see in a moment, one of the key things that is beneficial regarding diagrams is that, that this visual representation of the information provides all kinds of benefits. And actually a lot of research has been done in that corner of what are all different concerns that may have an impact on how well diagrams can be read and understood. Right, what is the difference between an ideogram and a glyph is being asked. So a glyph is an abstract symbol like a letter. And an ideogram is actually a picture that refers to a concept. So you see here, the envelope, you would not recognize this as a letter in our alphabet, or not as a, let's say, a symbol, but it's closer to a picture. Yeah, so Also, like, let's say a little user icon would be in the same category. But clearly there's a spectrum. Yeah. So if you think about how in old Egypt text was written, you can clearly see that there's a way how ideograms and images can transition actually into glyphs and text. Yeah. So there is a sphere where actually these two meet. All right. Yeah. So that means actually, let's say you can. That was also now being asked. You can actually partially also associate that with the role of these representations. So the ideogram, as the term says, is actually being used with the ambition to refer to a particular idea, and the image is then supposed to create some intuitive cognitive interpretation of this concept. While for the X, that's obviously not the case. You have to know actually that that this is actually related to the term exclusive, and that this is related to the semantics of the symbol. All right. So, but if you look at this here, I would like to take the chance to collect also a little bit of your knowledge again in the chat window. Maybe let's start with the strengths. What is good about having such a diagram? Why is it so powerful? Why is it better and easier, supposedly, and more useful than, for example, having a piece of text? If you have an idea, just drop an idea or a keyword into the chat window, and I can collect some of your thoughts on this here. So it's being said, it's formal, it's unique, and it provides a unique interpretation. Okay. Then we read there's secondary notation, so we can visually highlight things and we can benefit from the spatial arrangements. It can be more clear and at that extent also be more precise, such that we don't need to discuss how we interpret things. It's an overall view. That means a diagram can actually provide you with an overview about a certain matter. Here you can directly see the flow, so the arcs pointing in a particular direction. Let us just wait for a second if somebody is still typing. It can be concise. Yes, it's a very concise and compact way of how you capture that information. You can also highlight stuff. You can provide a focus for a particular matter. So I think this is something that it's it's quick to read. It's good to provide an overview. It's also being said, well, it's good if you lack patience. Yeah. So, but one thing that we can see is that that this visual representation comes along with a spatial nature of these diagrams, and if you compare that to text, it has different consequences of how you can actually navigate with that information. So, if you have a piece of text that shows the same information, typically, when you want to find a particular piece of information, you have to sequentially read through the full text until you actually arrive at that position where that information piece is being written that you're currently interested in. With diagrams, it is in this way easier because the diagram allows you to navigate the information not only in a sequential way, but you can navigate the information in any of the spatial directions here in a two-dimensional way, depending on which element you focus, and then depending into which direction you want to actually investigate the context of that. So for instance, if it was for me that, let's say I'm a process analyst and I need to think about how the delivery products activity is implemented in a workflow system, maybe the thing that I'm most interested in is what information do I get from the previous activities, and which kind of information do I need to provide to the subsequent activities. So visually, I can very quickly identify this delivery product activity, and then I can focus on those parts that are relevant. So that makes search much faster because we can rely on visual search. And visual search is something that for us as humans is very efficiently implemented in our brains. Yeah? So that actually makes it very helpful to foreground a particular part of the diagram and then actually to investigate and to navigate the context of that. So in this way, diagrams are actually much more efficient. And also when you look into research that discusses what in particular developers do, they very often need to foreground some contextual information about what they're currently doing. So they're working on a very narrow piece, but very often they have to refer back and understand, let's say, something like the bigger picture around this. And if this bigger picture is represented and made available to them, for example, as a diagram, they can very quickly navigate this. All right. So now with this background, let's look again at our overall CogniDia framework, where we can now see actually how that helps to see how everything puzzles together, and also how we can see that that we can separate certain concerns. Yeah. So as being said, the diagrams are particularly helpful when they support and when they actually directly rely on those parts of the visual module that are implemented very effectively. So that's the visual search. This is where diagrams are very strong at, and the visual module can actually help to fetch the required pieces of information much faster. We also see here, we talked about the textual pieces. Diagrams have various pieces of text integrated. This is something that needs to fit into the verbal processing, but we can also see a little bit if, let's say, if the alternative is that we only have text and not a diagram. So the same information that we have in a diagram, if it was a text, we see that there would be actually much more cognitive workload on the verbal processing. And so that means actually much of, let's say, the textual parsing of identifying, let's say, what are verbs, objects, etc. Partially this is offloaded into the efficient visual processing already, because we know at an activity in such a process model, actually it's a verb phrase, a very short verb phrase, and we don't need to actually analyze a larger sentence to identify these pieces. So actually there we get these pieces of information much quicker. And all of this is then integrated at the semantic level. And at the semantic level, with our knowledge of what the different symbols mean in the model, this is enriched. And also with what we have as an understanding of the domain, and this is enriched, and that gives us an overall mental model of what this diagram is trying to say. And this is what we then use for solving and working on our particular task in the system and design process. So what is interesting now, if you look at the literature, we can observe that the focus of prior literature has been on certain aspects of this, and it has given less emphasis and less attention to other aspects. I think this is most clearly if you see here that the visual processing has been covered in many papers over the last 25 years. You see also there's huge spectrum of research on semantic aspects of diagram quality and also language quality. These are topics that we have very researched in our domain and also in the neighboring domains in the last decades. What we have much less looked into is actually the verbal processing. So what do we do with these textual pieces in our diagrams? And also how actually the diagrams are then actually intertwined with the task processing. This is something where there are various opportunities of conducting future studies, as we'll also try to emphasize later. Okay, so that means for the moment I take this intermediate summary in stating that we see that we can distinguish different concerns in cognitive processing of such diagrams. We observe that the visual processing has been intensively researched in semantic processing, and what we have not yet discussed is, well, let's say, what are the criteria that make a difference if a diagram is a good one? So it means if I have a diagram, let's say, colloquially said, I can still mess up things by using a diagram, but using it in an ineffective way. And this is what we actually try to understand from the literature. What is the whole spectrum of all kinds of different criteria that have been discussed in the literature that informs us of how can we do it right? How can we actually provide diagrams that are very effective to use? So I want to illustrate this a little bit with a few examples. So the list of criteria that we identified in our literature study is extensive. It's 220 different criteria that we have identified only in these 4 categories of these 4 cognitive processing steps. We abstracted them into 22 categories. And I want to emphasize a few of these categories and criteria that are associated with these categories with the following examples. So it means, let's start on the left-hand side and look at visual processing. So if we consider visual processing, prior literature has identified a whole long list of different criteria that can be grouped into these 7 categories as you read them here. So they're visual aesthetics. They're mainly discussed in graph drawing research. That means actually how we can draw graphs in a nice way. There's visual consistency, visual simplicity, pop out of elements that are important and that are of interest. Grouping, so that we can identify which things belong together. And then also regarding the symbols, in how far we can distinguish symbols. And in how far those, if we look at the symbol in isolation, how far that symbol is clear. For example, if we look at an ideogram, that this envelope actually is suggesting that there is information passing that can be helpful as compared if we would use some abstract symbol for it. So let's look at an example where we can see the relevance of this. One of the most important concerns on the visual side is where we can do diagrams nicely or not nicely is in terms of layout. And if you look at these 2 examples here, you may actually find it difficult to understand at a first glance that this is actually the same process. And it's not the same process, let's say, from a domain sense, but actually the diagram is exactly the same from a logical perspective. So it's the same elements connected by the same arcs. But we can very clearly see that that the layout that was chosen on the right-hand side has been done in such a way that the overall structure of the diagram is confused. So in on the left-hand side top, you see how this model can be actually arranged nicely. And this is a little bit, let's say, an example to make the point. Clearly, people in practice would shy away from creating a model like the one on the right-hand side. But it's actually a little bit more tricky. So in many large diagrams, in the model collections that we had available for research, we see actually that many models are actually not so nice like the one on the left-hand side, and maybe not so bad as the one on the right-hand side, but actually there are many actually in the middle, and where the layout is not optimal, where the designers have paid too little attention actually in trying to make things clear. And sure, that makes a difference. In some of our experiments, we can actually very nicely see that, let's say that having an extremely good and extremely bad layout has actually a strong impact. So then there's the concern of symbols. And for those of you who have some interest in process models, you might know that there have been different languages around for modeling processes. Partially, these languages differ in which kind of semantic concepts they provide, but they also differ in the way how they have been proposing symbols for partially the same concerns. You see this here, it's 4 different example processes in different notations. So on the left-hand side, EPCs, then we have UML activity diagrams, the YAWL notation, and BPMN on the right-hand side. And just by looking at it, and if I tell you, if you don't know these process models, and I tell you it's actually the same thing that they show, but they show it with different symbols, you may recognize one or the other thing that, let's say, first, you may be able to distinguish certain symbols better from one or the other notation. So on the right-hand side, the split and join points are quite well to distinguish. The one has such a bold plus sign, the other one is empty. While if you look at the second one from the right-hand side, that's the YAWL notation, you see that there are these small boxes with a triangle inside, and actually all of these boxes with the triangles, they are semantically different. However, you have to look very carefully to distinguish them. Yeah, so this is one of the examples where you see that actually the symbols and the symbol set can be chosen in a way that it actually makes a difference. And here in this case, you see we conducted an experiment, and we saw some clear effects of this. So, and there are many more studies that look into different aspects of visual design of representations and notations. You see that all of them, they belong into this category of the visual design. And you see also here, it's one of the concerns that you often face, that you have to, I have to make this a bit more quiet. And you see that actually that this has an impact, and that means also in your experiments, you need to make sure that you try to block the other factors so that you can really tease out your treatment. All right, so now let's look at verbal processing, an area of research that has received less attention, but is receiving more attention in recent years. And this is actually partially fueled with the innovations in natural language processing over the last 10 years. And in our own research, we have been looking into natural language processing techniques that can help us to make the text pieces of process models better and do all kinds of analysis on top of this. So, and what is, let's say, from a reader's perspective is important is the clarity of the text and the effectiveness of the presentation of the text. These two pieces come actually together. Just to give you an idea that text matters. Also here an example from one of our experiments where we try to actually contrast, let's say, extreme points. And on the right-hand side is a process model as we have seen it in an industry application. So this is one of the SAP reference models. And on the left-hand side, the same model with the same structure, but now the text has been shrinked down to letters. And what we see here is that, let's say, the sheer size of the text creates an effort for the reader and the interpreter of these models, such that when you ask participants to let's say to check, for instance, the model on the left-hand side, if certain activities appear in a certain order or if they're exclusive, that this is much easier for humans for the model on the left-hand side, as if you give them the model on the right-hand side, because on the left-hand side you have a clear and very short index for each of the activities. On the right-hand side you have a text that almost stretches over 3 lines in some of the elements. And that consumes cognitive capacity for the detriment of other sorts of cognitive processing. Yeah, so there are not too many experiments who look at such phenomena, and it's very interesting actually to study that in more detail because it's very much at the heart of diagrams in our research domain, being a mixture of visual elements with textual pieces of information. So let's look at 2 specific aspects in terms of the semantic processing as well. So this is, let's say, a research domain that is even larger than the visual processing in our domain. Much has been done in terms of understanding modeling languages and using ontological perspectives on this, and that is a large that research has a large tradition in our research domain. Just give me a second. There was one more question. All right, so there was a question to the previous experiment. I would say it's a comment about external validity, asking, well, if you only have letters, don't you lose the semantic context of this model? That is absolutely right. Yeah. So our experiment there was focusing on the verbal processing and not on the semantic processing. Yeah. So clearly, with the letters, you don't have any, well, you kind of break the connection to any sort of background knowledge and domain knowledge. This is something that, of course, needs to be kept in mind, and it needs to be consistent when you design such an experiment with the objective of the experiment. All right, so let's look at the semantic processing. So let's say 2 sub areas of categories we need to distinguish. So the list is much longer, but actually here it's only the 2, let's say, top level categories. There are semantic processing aspects of individual diagrams and aspects that are associated with the modeling language being used. Let's first look at this example here, because I think it nicely connects with the question that was just raised and the previous experiment, which was focusing only on the verbal processing. And this is an experiment here, which was done by Bera and other colleagues, where they created models that were structurally similar. So this is not now that this is the same model, but where they created models that were anchored in different domains, and where they showed same models on the one hand side in the context of library, and on the other hand in the context of some neuromedical concerns. And if you now just read through what is written in these diagrams, you will see on the left-hand side, it talks about the hippocampus, location, size, shape, interferes, neurotransmitter types, memory impairing agents, glucocorticoid, etc., things that we, even as non-medical researchers, have difficulties in only reading out the terms. And then on the right-hand side, you have things that everybody knows, things that happen in the library. In there, which is interesting, that actually when using these diagrams in experiments, actually you can see that participants perform much better with, let's say, the same diagrams in a more everyday domain than in the domain that they could not relate or connect to. That of course raises interesting questions in how far, to which extent those diagrams are connected with background knowledge, but also in how far this is also partially anchored into the verbal processing. This is actually practically very relevant. But also here, this is one of the few experiments that go into that direction, and there are clearly opportunities for doing more on this. So what also many of you know, a semantic perspective that is often used for discussing the quality of modeling languages are ontologies and ontological concepts. There are different pillars for that research. There's the work that was initiated by Wand and Weber. There's the research that have been triggered by Giancarlo Ghisardi and others. All of these different researches provide one or the other aspect for an ontological discussion. What is the bottom line of that research is that once you have ontological deficiencies in your languages, this is something that also has a negative impact on the interpretation of these diagrams. So here in this example that you see here on this slide, you see that on the left-hand side, the diagram explicitly captures reservations. And that is consistent with some of the guidelines that Vera and others have been proposing. But on the right-hand side, you see that, let's say, this interacting class here of reservations is hidden behind the arcs that connect service provider and customer, and that is to the detriment actually also for making inferences around these diagrams, and actually for the requirements validation, it has a negative impact. All right, and of course, while we try to separate these different concerns, of course, one of the challenges in practice is that that these issues are intermingled in real examples. Here on the left-hand side, you see a diagram that we have in our textbook. And I always have to emphasize this diagram is not so stupid because we actually invented it to be so stupid, but it's actually one of the diagrams that one of our co-authors encountered in a real industry project. Yeah, and the model on the left-hand side has various problems. So the textual labels are inconsistent. The structure is terrible. And in this way, it kind of obfuscates what really happens in this process. And the interesting thing is, if you now try to refactor that model, you can arrive at the model on the right-hand side, and it's really strikingly different to the model on the left-hand side, even though it talks about the same process and it also captures the same activities. with the only difference that that textual labels are cleared, and that the control flow structure is made much better visible. Yeah, so that means actually then in practice we have to identify different concerns and different violations and weaknesses of different criteria can be encountered, and all of them sum up. Right. So with these observations, I progress towards the right-hand side, and I believe that is the most interesting step of cognitive processing for us to research in future research, and that's the task processing. So in task processing, also the literature partly talks about one or the other criterion. In how far diagrams fit users, fit the goals, that means the tasks that we are facing, and in how far the language is overall appropriate. There's not much being done with this, but it will actually be very interesting to work with this more. I just show you one direction where this could actually go in future research. Again, here I refer to two different alternative representations, where one of them is a process model and the other one is an informationally equivalent piece of text. So with, let's say, the intuition that we have been building up right from the start, I want to ask the question, and maybe show me your hands again. Who would say actually that the diagram is better? Anybody raising their hand? Right, one or the other person. Okay. Then, okay, please drop your hands, and I want to see if the rest of the group is awake. So who thinks the text is better? So I cannot see anybody raising their hand. So it leaves me a little bit with the question, if this does not add up, maybe I have to ask. So is there anybody who would say it depends? All right, some more hands. Also, I see some people raising their hands again, who actually said that the model was better. Okay. Wait, maybe let me briefly look into the chat window. Yes, it's not yes and no. It depends. Yes, they're both good. Okay, this is an interesting point. Okay, let's look at this a little bit more detailedly. Yeah? So with what we discussed so far, do we have any angle in understanding that better? So the interesting point is actually, yes, it depends. And the question is interesting, it depends on what. And our point that we're making here in this experiment paper is it depends on the task. Yeah, so, and if it depends on the task, it is actually a fit that we need to consider with between the task and the representation. And just to show you a little bit of, let's say, how drastic that is, so we try to actually find tasks that we could somehow position on a spectrum between, let's say, tasks that clearly benefit from the visual nature and visual search of the diagram towards tasks that supposedly have a strong affinity with the text. So of course, this is being done a little bit with internal validity of the experiment in mind. So it's a little bit decoupled from, let's say, a practical application context of these diagrams. But what we see here on the left-hand side are the diagrams is a task that has a very strong affinity with this visual characteristics of the diagram. And you see that BPMN is in each of the boxes on the left-hand side on the left, and the text is on the right. And the higher, the better. So it means actually the scores are much higher for BPMN than for text for this task. So if you look at the very right-hand side, you see that there we chose a task that was very intentionally chosen to supposedly have some affinity with the text. And it was a so-called CAiSE test. CAiSE test means you take a text and you leave out certain words, and then you ask the participants to fill in those blank words. And of course, if you have the same text earlier being received and written, and even if that text is not available to you anymore, and you try to fill in, it's easier to recognize the overall sentence structures and flows that you have read before, than actually if you have to think about the diagram and translate the diagram into these text sentences that you read. And there actually, we could see that with this CAiSE test, those who had received earlier the information as a text did actually much better than those who earlier saw the BPMN model. So, and what is now interesting is, of course, that, well, these are the extreme cases, but let's say what is, let's say, a more practical setting is that what happens if actually we have not such narrow and specific tasks, but if we, let's say, have larger tasks in a practical setting that are associated with problem solving. And this is what you see in column number 3. So the second from, if you look at from the right-hand side, there actually it's not so conclusive anymore. Yeah, so that clearly emphasizes the need that we need to understand our tasks better, so that we can actually understand how beneficial diagrams are for supporting that. All right, so what does all of that mean? Let me try to summarize at this stage that we can still discuss this a little bit further. What are implications that we see from this work? Well, one of the implications is that we actually identified a whole catalog of research questions that would be interesting to investigate, and for which very, very little research have been done. So when it comes to the visual processing is one of the things that we observe that this research is very much driven from a, let's say, a rational processing perspective. So there's not too much of actually a recognition that decision making and cognitive research has been focusing on dual process theories of cognition. So it means that there is effect, that there are heuristics, that there are biases, and one or the other may know this nice book of Daniel Kahneman. This is exactly the sphere about which we're talking here. And there's also plenty of research in the information visualization field that talks about anti-patterns or fallacities of interpreting visual information wrong. I haven't seen much into that direction in our domain. The second one is that there's plenty of opportunities of understanding better how actually diagrams relate to their textual pieces, and in how far, let's say, these textual pieces transition into a good understanding. So theories of reading can be helpful here. Also there, not much has been done in our area. Which is a little bit funny, because if you look at a diagram and when people read it, they read the pieces of text, and that makes a large share of domain understanding of what these text pieces are. Yeah? So it's actually surprising that we have not studied that deeper for the moment. In terms of diagram understanding, there's a lot of things that we can consider in terms of what research into sense making has been done. There are corner theories like representation theory and formal ontology, which is informative for that. And in particular, let's say if you take the diagram and how far the diagram smoothly or not smoothly integrates with background knowledge, let it be on the ontological level, but also being it on the domain level. This is actually very important because in the end, when people work on tasks, it's not the diagram as such which they have at hand, but they have the diagram in their mind, plus how that diagram connects with different background information. And for that diagram foregrounds different pieces of their background knowledge. So it would be very interesting to study that more. So and finally, when it comes to the task perspective, I think I have emphasized that, let's say, we need to understand our tasks better. That means we need characteristics of tasks. We need to understand them better. Maybe we also can benefit from task taxonomies that can be built, or taxonomies being developed in other domains, and how far we can adopt them to our field. Yeah, so, and partially then, this is a discussion how these tasks interact with external cognition. And external cognition means, on the one hand side, how I, if I'm trying to solve a task, read a diagram that is not in my brain, but where I fetch information from the diagram to reflect. And also how that actually feeds and supports a distributed cognition, in particular in those scenarios where you can think of developers standing in front of a whiteboard and sketching out some notes in how they, I don't know, how they may want to organize the architecture of the next module that they jointly are supposed to build. So also there are many interesting questions on it. All right, yes, some comments emphasizing one or the other point here. One is pointing to Machiavelli. Then there's another pointer to dyslectics. Of course, it could be interesting to perspectives to think about these things. Okay, finally, let's say what has been largely a theoretical discussion can also be translated into some practical guidelines. That means each of the categories that we identified in our study bears the potential that we could reformulate them as guidelines. And I think these guidelines provide a basis also for informing future research, let's say, into methodological support for designers of diagrams, how far they can make use of these guidelines in training, but also now for tools that can help designers to support them creating models that are good in all of these regards right from the start. All right, so that means I believe there's much to be discussed in future research, and before I close, I want to direct your attention onto a call for a special issue that is, let's say, partially related to us, to this tutorial, but I believe many of you could be interested in this call for papers. It's a special issue that we will have in the BZ journal, and there's still a bit of time. So in January, there's the deadline for submission. And with that special issues, we are interested into the impact that BPMN had as a language. Please go to the website of that call and read a little bit into different research questions that we can think of and different problems that are related to, let's say, the adoption and the use of BPMN on various levels. And we're very curious for seeing your submissions. But with this, I'm sorry for this short advertisement before the end. So instead of a summary, I want to put up this research question slide up again. So maybe this can be an anchor for one or the other person in the audience for raising one or the other question or raising one or the other comment. And I would be happy that we can use these remaining 10 minutes still for discussing So, and with this, I open the floor to discussion, and I think the privacy rules are that we should now stop the recording because we have not the consent of all the participants. But I